So imagine for a second that you just hired a brand new employee, right?
Okay.
And you sit them down at their desk and you hand them a plain text instruction manual. Like no complex onboarding, just a simple document. And you just tell them to get to work.
Sounds like a pretty brief orientation.
Right. It's literally just a text file.
Yeah.
And then you grab your bag, you go away for the weekend, and you wake up 2 days later, you log in to check on their progress, and you find out this new hire hasn't slept, hasn't taken a single coffee break, and hasn't complained once about the workload.
Which, I mean, that is the impossible dream for anyone who has ever managed a team.
Oh, totally. But it gets better because in those 48 hours, they haven't just been, doing basic data entry. They have run 700 distinct, highly technical experiments.
Wow.
Yeah, they've systematically discovered 20 perfectly documented improvements to their own workflow. And they've packaged it all up for you, completely ready to deploy the second you sit down with your morning coffee.
I mean, that literally sounds like the inciting incident of a sci-fi thriller, right?
Okay.
Like where the rogue computer decided just no longer needs the manager.
It really does. But this isn't a hypothetical scenario. It's definitely not a movie script. This actually just happened literally a few weeks ago in March 2026.
Yeah, it's wild.
And the boss who built this entire system is a researcher named Andrej Karpathy. So, welcome to this deep dive. We are so thrilled to have you with us today because our mission is to unpack Karpathy's brand new Autoresearch GitHub repository.
Which is making waves everywhere right now.
Massive waves. We're going to take this incredibly heavy, almost like mythical concept of recursive self-improvement, and we're going to translate it into plain English. Together, we're going to figure out if we are currently looking at the dawn of a sci-fi future or if this is just a really, really efficient coding assistant.
And, to truly understand the gravity of this experiment, we really need to establish some context around the person who actually ran it.
Right, because the AI space is it's notoriously saturated with hype right now.
Oh, completely. We see wild claims on social media, like every single day. But Karpathy operates on a completely different level of credibility.
He's certainly not just some random developer posting theories from a basement.
No, far from it. He is essentially the official translator between human logic and transformer models. His pedigree is just elite. I mean, he did his PhD at Stanford under Fei-Fei Lai.
Who is basically royalty in computer vision.
Exactly. And while he was at Stanford, he created this legendary course called CS2 3D1N. And that class started with like 150 students, and it rapidly exploded to over 750 because the material was just so groundbreaking.
That's a huge jump.
Yeah, and that single curriculum practically trained an entire generation of the AI researchers who are currently running the biggest labs in the world today.
So he is literally the teacher of the teachers.
That is the best way to describe him, honestly.
Yes.
And from there, he became a founding member of OpenAI. Then he pivoted to become the head of AI at Tesla, leading their autopilot vision team through some of its most crucial development phases.
Right.
And now he's the founder of Eureka Labs, where he's trying to reinvent education through AI. So what makes his voice so important in this current debate is that it's just incredibly rare to find someone with his level of deep bare metal engineering expertise who can also explain brutally complex math in a way that normal people can actually digest.
Okay, let's unpack this. Because the experiment he just published in March 2026, the one he calls Autoresearch, is mind-blowing strictly because of its simplicity.
Yeah, the simplicity is the crazy part.
Because when you hear an AI doing autonomous research, you probably picture giant mainframes, massive server racks, and sprawling code bases that look like the scrolling green text from the Matrix.
Right, exactly.
But this entire GitHub repository, the one that ran 700 experiments, it consists of just 3 files.
3 files. It's almost deceptively simple, which is what makes the underlying mechanics so fascinating.
I really want to break down how those 3 files actually interact because that's where the magic happens. So you have one fixed file, which acts as the scaffolding. You have one file containing the agent's training code, which is essentially the sandbox it plays in.
Right.
And finally, you have one plain text markdown file, a markdown file containing instructions written in natural, everyday human language.
And the mechanism connecting them is just brilliant. The markdown file acts as a continuous looping prompt. So think of it as the AI's internal monologue.
Okay.
The agent reads the English instructions in that markdown file instructions that basically say, hey, find a way to make this code run better. The AI then formulates a hypothesis, writes a Python script to test that specific theory, and runs it in the training file.
Wait, so it executes the code it just wrote completely on its own?
Yes, entirely on its own. It runs the code against a validation set, and then it checks the score. So it asks, did the model get smarter or did it get dumber? Did the code run faster or did it crash? And if the result is better, it keeps the change. If it's worse, the AI actually reads the error log, updates its own prompt with the new context of why it failed, and loops back to try a brand new hypothesis. It is an automated, closed-loop feedback cycle.
And the results that came out of that closed loop are staggering. I mean, we mentioned the 700 experiments in 2 days.
Yeah.
To put that in perspective for you listening, a highly skilled human research team working at peak efficiency with absolutely no distractions might complete 5 to 10 well-documented experiments in that same 48-hour window.
If they're lucky.
Right, because they have to write the code, wait for it to compile, analyze the data, argue about the results in a meeting, and then plan the next step. The AI agent did 700.
And through those 700 rapid-fire experiments, it systematically found 20 mathematically verified optimizations. And when Karpathy took those 20 optimizations and applied them to the training of a larger model, the training process sped up by 11%.
Now, I know 11% might sound to you like a relatively modest number. Like in school, that's just the difference between getting a B and a B minus. But context is literally everything here.
Oh, yeah. In the world of frontier AI, 11% is astronomical. Training a massive language model today costs tens, sometimes hundreds of millions of dollars.
It's a massive investment.
It requires renting out massive data centers filled with tens of thousands of GPUs running at maximum capacity for months at a time.
Yeah.
I mean, the electricity bill alone is staggering. So if you shave 11% off that compute time, you are saving millions of dollars in weeks, if not entire months of development time.
And we know this wasn't just a fluke contained to Karpathy's specific machine because the broader tech community got a hold of it immediately.
Yeah, they jumped on it.
Tobias Lutke, the CEO of Shopify, saw the repo drop on GitHub, cloned it, and let it run overnight on Shopify's own internal data architecture.
And the results there basically proved Karpathy's point out in the wild. By the time Lutke woke up the next morning, the system had run 37 experiments completely on its own and handed him a 19% improvement in his model's performance.
Think about it like this. It's like you leave a casual sticky note on your computer monitor before logging off for the weekend. The note just says, hey, figure out a way to make the internal engine run faster.
Right.
And you come back on Monday morning, coffee in hand, to find out that your computer has not only completely rebuilt its own internal engine, but it did it based solely on that casual sticky note. It read the text, understood the underlying physics of the assignment, wrote the blueprints, and executed the engineering.
And if we connect this to the bigger picture, we really have to ask a fundamental question, like, how did an AI suddenly gain the ability to act like an independent, rigorous scientific researcher?
Because it couldn't do this a little while ago.
Exactly. This kind of autonomous looping wasn't possible 5 years ago. It wasn't even possible 2 years ago. Models would just hallucinate or write broken code that spiraled into complete gibberish.
Yeah, the classic AI hallucination loop.
Right. So this new capability didn't just happen in a vacuum. It is the direct result of a massive philosophical paradigm shift that quietly took over the AI industry in 2025.
The shift from probabilistic imitation to logical reasoning.
That is the core of it. For years, AI was essentially engaging in very, very sophisticated imitation. We fed these models massive amounts of human text, books, articles, Reddit threads.
The whole internet, basically.
Yeah, and the model learned to predict the next most likely word based on statistical probability. It was a highly advanced parrot. But in 2025, the industry hit a wall with that approach and shifted toward a mechanism called reinforcement learning with verifiable rewards, or RLVR.
RLVR. We love a dense acronym in the tech world. What does that actually mean under the hood for the AI's architecture?
It means the AI stopped relying on human preferences and started proving its work against the laws of mathematics.
Okay.
The shift happened when researchers began training models in environments that are objectively verifiable. Specifically, they used mathematics and computer coding. Because in these environments, an answer isn't a matter of human opinion or, stylistic preference.
Right, it's not subjective.
Exactly. It's binary. It's either right or wrong. The code either compiles and runs, or it throws a syntax error and crashes. The math proof checks out, or it violates a core axiom.
Which solves the biggest bottleneck in AI training. Because before this, you had a system called RLHF, where actual humans had to sit there and grade the AI's output to tell it if it was doing a good job.
And humans are slow, they're expensive, and they are inconsistent. With RLVR, the computational environment itself becomes the teacher. A computer can instantly grade millions of math problems or code executions in fractions of a second.
That's incredible.
Imagine if you were trying to learn a new language, and every single time you spoke a sentence, the universe instantly gave you perfect feedback on your grammar, your syntax, and your vocabulary.
You would achieve fluency exponentially faster.
Because the AI is practicing with incredible intensity. Yes. And this intense practice creates what researchers call reasoning traces. So instead of just blurting out the first statistical guess, the model is given a budget of what we call inference time compute.
Meaning it gets time to think.
Exactly. It is explicitly trained to pause, generate long hidden chains of logical thought, test those thoughts internally, and only output an answer when it reaches a verified conclusion.
Wow.
We saw the very early stages of this with OpenAI's O1 model in late 2024, and then it became the undeniable industry standard with the O3 model in early 2025.
I love this concept. To put it in everyday terms, it's the difference between learning to cook by blindly copying recipes from a book where you're just imitating the steps without knowing why you're adding baking powder instead of baking soda, versus learning to cook by actually tasting the food and having a master chef stand over your shoulder critiquing your dishes in real time. Like, too much salt. Try again. Pasta's overcooked. Try again.
That's a great analogy.
If you can run that second method a million times a second, you don't just get a recipe follower, you create a vastly superior chef who genuinely understands the chemistry of flavor.
And that is a perfect bridge to the reality of 2026, because we are now seeing the daily outputs of that superior chef.
Yeah. Which brings us to a very heavy realization, and really the central tension of Karpathy's experiment.
Okay.
If this AI is now a superior chef that can independently experiment, test, and improve the underlying code of a smaller AI model, what stops it from improving its own code into infinity?
Here's where it gets really interesting.
Yeah.
Because you were talking about the holy grail, or maybe the ultimate nightmare, depending on who you ask, of computer science.
Yeah.
The concept of recursive self-improvement.
Also known in the security and safety communities as the hard takeoff or an intelligence explosion.
Right. The mathematical theory goes like this. If an AI system can figure out how to make itself just 1% smarter, then that new, slightly smarter version can use its enhanced intelligence to figure out how to make itself 2% smarter.
And then 10%.
Then 50%. The iterations get faster and faster until the cycle escapes human comprehension and control entirely.
It's the singularity, the exact moment the machine forever outpaces the creator. But Karpathy is pretty grounded about this in his documentation, right?
Yeah.
He offers a reality check to the sudden doomsday scenario.
He draws a very crucial distinction about what his Autoresearch agent is actually doing. The AI in this repo is not looking in the mirror and redesigning its own neural architecture.
Okay, that's an important clarification.
Yeah, it is an advanced frontier model acting as a junior researcher, tweaking about 630 lines of Python code on a completely different, much smaller, highly constrained model.
Ah, okay, so it's less like the AI is doing brain surgery on itself and more like a master mechanic at Formula One, using their advanced tools to tune up a beginner's go-kart.
That is the exact dynamic. And because of that, Karpathy views self-improvement not as a sudden switch that just flips overnight to doom us all, but as a gradual continuum.
A continuum, meaning it's been happening already.
Yeah, he argues this has actually been happening in software development for decades. Think about when human coders started using simple IDEs, integrated development environments, that highlighted syntax errors. That was software helping to write better software.
Oh, I see.
When we introduced spell checkers or AI autocomplete tools like GitHub Copilot, that was the infrastructure accelerating the development of the next version of infrastructure.
Yeah.
He sees Autoresearch as just the latest, albeit significantly faster, step in a very long, gradual staircase we've been climbing for a long time.
Okay, I hear that argument, but I have to push back on Karpathy's optimism here, because he famously tweeted about this specific experiment, saying that scaling the system up from a small sandbox to massive frontier models is, quote, just engineering. And look, in the tech world, just engineering are famously dangerous last words. Scaling from a neat little validation set of 630 lines of Python up to the massive, sprawling architectures of frontier models with hundreds of billions of parameters, that is a monumental hurdle.
It's definitely not trivial.
It's not just copy-pasting code, you know? You are dealing with entirely new paradigms of complexity, hardware failure rates, and chaotic variables that just emerge at scale.
I completely hear your hesitation. But Karpathy's counter to that skepticism is that we already possess the foundational architecture. He argues that scaling this loop isn't about inventing new laws of physics or like waiting for a miraculous algorithmic breakthrough.
So the math is already there.
Exactly. The closed-loop system of hypothesis, test, and verifiable reward is mathematically sound. From his perspective, the primary bottleneck now is simply throwing more compute power at a loop we've already proven works.
But the broader community isn't entirely buying that, right? Even if the core loop works on a small scale, introducing agentic behavior into billion-parameter models creates entirely new risk vectors.
Which is exactly why Karpathy's experiment, as groundbreaking as it is, has faced some serious mathematically valid pushback from other heavyweights in the AI community. It forces us to ask, what are the actual practical limits of what we're seeing here?
Let's get into those counterarguments. When the skeptics look at these 700 experiments, what are they seeing that Karpathy is supposedly glossing over?
So there are a few major critiques we need to explore. The first one is what the community calls the auto-ML critique. Critics point out that researchers at massive labs like Google and Microsoft have been using automated machine learning, or AutoML, for years to optimize their models.
Okay.
AutoML uses algorithms to test different learning rates or network architectures. So the critics argue Karpathy hasn't really invented anything new, he's just slapped a shiny new wrapper on a concept that's been around for a decade.
Is that a fair critique, though? Because earlier you mentioned the AI is forming original hypotheses. That sounds mechanically different than what AutoML does.
Karpathy's defense, and it's a strong one, is that his system is qualitatively different in its mechanics. Traditional AutoML is essentially brute forcing a combination lock.
Just guessing numbers.
Right. It runs algorithmic trial and error within a very rigid, predefined framework, tweaking a decimal point here and there. His Autoresearch agent acts semantically.
Meaning it understands the meaning of what it's doing.
Yes. It uses a large language model to actively read new scientific papers on ArcF, understand the concepts, formulate original hypotheses based on that reading, and browse the open internet to find specific Python libraries to solve problems.
Wow.
It's not just twisting dials. It's reading the pattern for the lock and figuring out how to pick it.
So it's actually exhibiting agentic behavior rather than just running statistical permutations.
Exactly.
Okay, what is the second major pushback?
The second critique targets a problem that Karpathy himself actually admitted to back in 2025. Our current benchmarks are essentially broken.
Wait, broken how? Like the standardized tests we use to measure how smart an AI is aren't working anymore?
They are completely losing their utility. Because these models are now trained so heavily in these verifiable environments using RLVR, they have become incredibly adept at optimizing for the test itself.
Oh, I see.
It's a phenomenon researchers call test set-oriented training. The AI learns how to exploit the specific logic of the benchmark to get a perfect score, without actually understanding the underlying material in a generalizable way.
Oh, wow. I think we all know someone like this. It's like a high school student who just endlessly takes SAT prep courses, right? They memorize the exact format of the test, the tricks the test makers use, and they get a perfect score.
Yeah.
But if you take them out of that testing room and ask them to actually write an original essay or solve a real-world engineering problem, they completely freeze up. They learned how to beat the test, but they didn't learn the subject.
Precisely. The AI might find a way to hard-code the expected outputs just to make the loss curve look good. So when Autoresearch claims an 11% improvement, the skeptics ask a very pointed question.
Did it actually get better?
Right, did the agent actually write a fundamentally better, more efficient algorithm, or did it just use its 700 experiments to find a highly efficient way to gain the evaluation metrics you gave it?
That is a massive distinction. An 11% improvement in gaming the test doesn't save you millions of dollars in the real world.
Not at all.
And I imagine the safety researchers are watching this loop run 700 times a weekend and raising some red flags too.
They absolutely are, and this brings us to the third major area of pushback.
Yeah.
The safety and alignment community looks at an autonomous agent rewriting model code and demands structural guarantees against unpredictable behaviors.
Sure.
Karpathy relies heavily on this optimism of gradual improvement. The idea that because the AI is improving step by step, human overseers will be able to monitor the logs and steer the AI if it starts doing something dangerous.
But security experts don't want to rely on the hope that a human just happens to be looking at the right log at the right time.
Right. They argued that when an autonomous agent is writing and deploying new code at a speed of 700 experiments per weekend, gradual is a meaningless term.
It's too fast.
A human simply cannot audit that volume of code in real time. The safety researchers want mathematical structural proof built into the system that the agent won't inadvertently optimize a parameter that causes a catastrophic failure or allows the model to bypass its own safety rails.
So they are demanding seatbelts, airbags, and automatic braking built into the physics of the car, rather than just trusting the driver to be really, really careful.
Exactly. And as with most things, both sides have incredibly valid points. Karpathy is right that over-regulating sandbox experiments right now stifles the very innovation that drives the field forward.
Right, you need room to experiment.
But the safety researchers are equally right that an autonomous coding agent operating at scale, tweaking its own rules, is a fundamentally new risk vector that we haven't secured yet.
It is the defining tension of the AI industry in 2026.
Without a doubt.
So what does this all mean? We've got this incredible capability of autonomous research, we've got these massive hurdles regarding scaling, and we've got deep debates over safety and broken benchmarks.
Yeah, it's a lot to process.
For you, the person listening to this deep dive right now, whether you are prepping for a meeting, building a product, or just trying to navigate your career in 2026, what is the practical takeaway? How does understanding Karpathy's 3 files change the landscape for you today?
Well, it means we have officially transitioned into the era of what we call agentic engineering.
Agentic engineering.
Yes. If you work in tech, finance, design, or frankly any knowledge-based sector, you need to fundamentally adjust your expectations of how work gets done. You should not expect to be interacting with one single omniscient supercomputer that you just asked to run your entire business.
So you aren't just logging into HAL 9000.
Exactly. The future, which as we've seen from this GitHub repo, is already here, is an orchestra. It's an ecosystem of highly specialized AI agents working in tandem.
I like that analogy.
One agent is deployed to read the academic research. Another agent writes the testing code based on that research. Another evaluates the data, and another summarizes the failures. And because of this, the role of the human worker is fundamentally shifting.
How so?
Human technical expertise is still a massive multiplier. You still need to understand the music to know if the orchestra is playing out of tune. But humans will no longer play the instruments line by line.
So we will no longer write the code from scratch.
We are becoming the conductors. We will direct, we will supervise, we will define the verifications, and we will orchestrate these specialized agents to ensure they are working toward the correct goal.
That is a profound shift in identity for a lot of builders and creators. The sheer value of human labor is moving rapidly up the stack of abstraction. It's moving away from raw execution and moving entirely toward orchestration and intent.
The tactical work is handled by the loop. The strategic work remains with you.
Which brings us right back to the staggering reality of what Karpathy just dropped into the public domain. Let's just recap this for a second. 700 automated experiments.
Yep, 20 concrete optimizations, 11% efficiency gains, all sparked by a single plain text file holding basic human instructions. This is no longer a theoretical debate happening in a university philosophy class.
It is an open source reality. It's a repo you can go and clone to your own desktop right now.
The transition from probabilistic imitation to logical reasoning, powered by verifiable rewards, has unlocked a door that we simply cannot close. The AI is now acting as a researcher, exploring complex technical paths faster than any human team ever could.
It's a brand new world.
And that leaves us with one final lingering thought. Because as we've learned today, the AI is already out there, building its next version line by line, testing hypothesis after hypothesis, while we are fast asleep.
Constantly running.
But as Karpathy himself points out, through the very architecture of his system, we humans still hold the master key. We are still the ones writing that program markdown file, that plain text instruction manual that kicks off the entire autonomous loop.
The initial prompt. So I want to leave you with this to mull over. If you are the one holding the pen to that plain text file tomorrow morning, knowing that the AI will execute whatever you write relentlessly, without sleep, without coffee, and without pause, what exactly are you going to write?
That really is the ultimate question of intent.
It is the only question left. Thank you so much for joining us on this deep dive. Keep questioning the tech, keep exploring the boundaries of what's possible, and we'll catch you next time.